Galaxies are the building blocks of the universe. They are massive collections of stars, planets, gas, dust, and dark matter, bound together by gravity. Every star you see, including our Sun, lives inside a galaxy. For nearly a century, astronomers have classified galaxies into three main groups: elliptical galaxies, spiral galaxies, and irregular galaxies. These three families are not just different in shape, they differ in age structure, star formation, and even where they live in the cosmos. Today, we're going to dive deep into the unique traits of each type, compare them side by side, and uncover the cosmic stories that make each galaxy family one of a kind. This is not just astronomy. This is the story of how our universe takes shape. Let us start with the first, and often the most massive, family: elliptical galaxies. If you imagine a galaxy as a shape elliptical, galaxies look like smooth, featureless ovals or spheres. They have no spiral arms, no thin disk, and no chaotic clumps of bright gas. Their name says it all: elliptical, meaning they follow an elliptical or oval form. Some are nearly round like a basketball, while others are stretched flat like a football. Unlike other galaxies, they have very little internal structure. When you look at an elliptical galaxy through a telescope, it appears as a soft, uniform glow, with no sharp edges or bright patches. This smooth look is one of their most defining features. What makes elliptical galaxies so different goes beyond their shape. They are mostly made of old stars. Think of them as the senior citizens of the galaxy world. The stars inside elliptical galaxies are mostly red giants and old cool stars that formed billions of years ago. There is very little free gas and dust left in these galaxies. Gas and dust are the raw materials for new stars. Without them, elliptical galaxies almost never form new stars. They are quiet, calm, and no longer active in creating stellar life. Most elliptical galaxies are also very large. Some of the biggest galaxies in the universe are giant ellipticals. One famous example is Messier 87, or M87, located in the center of the Virgo galaxy cluster. M87 is a giant elliptical galaxy that holds trillions of stars and a supermassive black hole at its heart. You almost always find elliptical galaxies in dense, crowded areas of the universe, like the centers of galaxy clusters. They thrive where gravity is strong, and galaxies often collide and merge over time. Now, let us move to the second family: spiral galaxies. These are the most famous and easily recognizable galaxies in the night sky, and our home, the Milky Way, is one of them. Spiral galaxies are structured like a cosmic pinwheel. They have three main parts: a dense, round, central bulge, a flat, thin disk that spins around the bulge, and long curving spiral arms that stretch out from the center. The central bulge is made of old stars, just like elliptical galaxies. But the disk and spiral arms are full of gas dust and young hot blue stars. This is where star formation is alive and active. The spiral arms are not just pretty patterns, they are waves of star formation. As the galaxy spins, gas and dust get compressed in the arms, triggering new stars to light up the cosmos. There are two main types of spiral galaxies: regular spiral galaxies and barred spiral galaxies. Regular spirals have arms that come straight out of the central bulge. Barred spirals have a long, straight bar of stars and gas across the center, with arms branching off the ends of the bar. Our Milky Way is a barred spiral galaxy. Another famous spiral is the Andromeda Galaxy, our closest large galactic neighbor, which will one day merge with the Milky Way. Spiral galaxies are bright, colorful, and full of energy. They are usually found in less crowded parts of the universe, on the edges of galaxy clusters, or in empty spaces between clusters. Unlike elliptical galaxies, they are still growing and creating new stars, making them some of the most dynamic objects in space. The third and final family is irregular galaxies. As their name suggests, these galaxies have no regular shape. They are not elliptical, they are not spiral, and they have no clear structure at all. They look like messy, glowing clouds of stars and gas, with clumps of bright star-forming regions scattered randomly. Irregular galaxies are the smallest and least massive of the three main types. Most are satellite galaxies, meaning they orbit larger galaxies, like the Milky Way or Andromeda. Their irregular shape often comes from gravitational pull from a nearby big galaxy, which tugs and distorts their structure over time. What makes irregular galaxies special is their extreme star formation activity. They are packed with gas and dust, far more than elliptical galaxies, and often more than spiral galaxies. This means they form new stars at a very high rate. The stars in irregular galaxies are mostly young, blue, and hot, making these galaxies shine brightly in blue light. The most famous irregular galaxies are the Large Magellanic Cloud and the Small Magellanic Cloud 2, satellite galaxies of the Milky Way that are visible from the southern hemisphere. Irregular galaxies are common in the early universe and are often found in small groups or orbiting larger galaxies. They are the wild cards of the galaxy world, unpredictable, full of energy, and always changing. Now that we've met each family, let's compare them directly to see their key differences. The first difference is shape. Elliptical galaxies are smooth ovals or spheres with no structure. Spiral galaxies have a bulge disk and clear spiral arms. Irregular galaxies have no fixed shape and look chaotic. The second difference is star formation. Elliptical galaxies have almost no new stars. They are made of old red stars. Spiral galaxies have active star formation in their arms, with a mix of old and young stars. Irregular galaxies have intense star formation, mostly young blue stars. The third difference is gas and dust. Elliptical galaxies have very little gas and dust. Spiral galaxies have moderate amounts in their disk and arms. Irregular galaxies have lots of gas and dust. The fourth difference is size and location. Elliptical galaxies are often large and live in dense galaxy cluster centers. Spiral galaxies are medium-sized and live in less crowded space. Irregular galaxies are small and usually orbit larger galaxies. These differences are not random. They tell the story of galactic evolution. Elliptical galaxies form when smaller galaxies merge together over billions of years. All the gas gets used up, and the structure becomes smooth and oval. Spiral galaxies form slowly, with gas settling into a spinning disk that creates spiral arms. Irregular galaxies form in small clumps, or get distorted by the gravity of larger neighbors. Every galaxy starts differently, grows differently, and ages differently. When we study elliptical, spiral, and irregular galaxies, we are not just studying shapes in space. We are studying the history of the universe. We learn how stars are born, how galaxies grow, how gravity shapes everything, and where our own Milky Way fits into the cosmic family tree. Our home is a spiral galaxy, but it lives near elliptical and irregular galaxies. We are part of a vast connected universe, where every galaxy has a role to play. Astronomers, using telescopes like the Hubble Space Telescope and the James Webb Space Telescope, keep finding new galaxies every day. They discover ancient elliptical galaxies that formed shortly after the Big Bang, distant spiral galaxies that look like our Milky Way, and tiny irregular galaxies that are bursting with new stars. Every new discovery teaches us more about how these three families evolved and how they will change in the future. The universe is full of wonder, and galaxies are its most spectacular creations. Elliptical galaxies are the quiet giants. Spiral galaxies are the dynamic pinwheels, and irregular galaxies are the wild star-forming clouds. Together, they make up the beautiful diversity of the cosmos. Number 2. Galaxies are exactly alike, but all follow the same rules of gravity, time, and stellar evolution. Whether you're an astronomy beginner or a long-time space fan, understanding these three galaxy types helps you see the night sky in a whole new way. The next time you look up, remember, every tiny light might be a galaxy, and it belongs to one of these three great cosmic families. The universe is not just a random collection of stars. It has a well-ordered, amazing world of galactic families that we are only just beginning to fully understand. Please like, comment, share, and subscribe to the channel.